Alright guys, so what have I been up to? I have been learning Fusion 360 a little bit more. I wanted a rubber band, and I saw there was some things on Thingiverse, but they were not quite the right size. So I decided to create some 20mm ones. So I simply measured these off, sketched out effectively a disc. You just go on here and you create yourself a cylinder, and then you can take that cylinder and turn it, add the or modify the cylinder by doing something called a shell, which strips away the inner components, and then set your thickness on that shell. I think I set mine for about 1mm or 0.5 or something like that. Now you need to experiment with your settings. But if I just show you a replay of this, that's effectively what it's done. So you create the you create the effect of the sketch. You then extrude it. So there's an extrude option. You've probably all seen it before, which allows you to draw up, pull up your disc effectively. Shelled it. You then go and modify and you shell it. And set the actual width, because you want the shell to be a certain width across here, and then delete the middle bit. You just click on the middle bit and delete it, because it tends to leave a little flat disc here, a very thin one. You just delete it, and yeah, you end up with that effectively. Then all you do is you save this. You must save it first as a project or a file, a version. And then once you've saved it, you can then go and export it, and then scroll right down the bottom. You can see there's an STL option. You can obviously export it in different formats. You can export it in Fusion 360F 3D, archive files, various other formats you can export in. But once it's exported, it goes online, by the way, and runs this through a Fusion 362 STL conversion. I think there's even a way to set this up for talking to Cura or to create output. I haven't looked into that yet, but I know it's capable of doing it. Once you end up with that, you're able to go into Fusion 360, bring in your STL file, which you can see here. Set your top and bottom thickness. So I've set my top and bottom layers to 2.2 and 0.42 and one wall thickness. And then when you have sliced it, obviously you can preview it. And there's a nice little feature here where you can hit play, and it shows you where the head's going to run on the top layer. I think I added a little bit of infill in here as well. Oh, maybe not. Maybe I didn't add any infill. It's doing it anyway because it's sort of included in the STL file. So there's no need for infill, in fact, because it is already of a certain thickness. If you've got a hollow section, obviously, you would have to infill it. So this one is a solid. It is a solid object because I created it as a solid object. I quite like this this play feature. And then what you can do with this play feature is go all the way to the bottom and just zoom in there a little bit, I suppose, and play again. And here you can see it printing the bottom layer. Yeah, that's pretty neat, isn't it? Depending on your graphics card, these colors change, by the way. I've got a really old graphics card in my old Dell XPS 1640, and it only displays a kind of reddish color. And it's all to do with the fact that it doesn't support OpenGL on Windows 10 for that old graphics card. And that's hard to find that information. Because I was wondering why on my desktop machine, which is, it's a good old Dell XPS 1640 is a brilliant, the solid state hard drive are fitted into it. It's a brilliant little lug of a laptop, you probably call it. But yeah, it just doesn't support the OpenGL. This is, well, I won't call it a weakness of Cura, it's just the fact that Cura supports OpenGL. Unless you've got OpenGL drivers on your system, you won't be able to get this nice it'll come up with compatibility mode up here, I think, rather than your choices of layer thickness and material type and line type. So that's a bit frustrating. So I'm using my primary laptop, which is a newer one, a couple of years old, whereas the Dell XPS, it goes back a bit. Cracking laptop though, the Dell XPS. It's got an amazing screen, the 1640. Bit of a collector's item now though. So you can see this doing its job. And then we simply send that out to Octoprint. What I'm going to do is we're going to duplicate this. Let's multiply the selected model by, say, I don't know, let's go for 6 and say OK. Right, so we now have 6 objects, which I quite like that feature. And let's slice that up. You could bring these a bit closer if you wanted, stop the head moving so far. In fact, why don't we see if we can arrange all, select all, arrange all. It's probably going to be about the same. Yeah, okay. So, yeah, they look good to go, don't they? So again, let's go and slice these up and make sure we've got everything set correctly. 5 minutes, that seems about right. And have a quick zoom in there, and they all look about the right thickness. Yeah, they all look about right. 5 minutes, 1 gram, and then a penny. And send those out. So I've already swapped out the, no, don't ignore that. I've already swapped out the PLA for TPU. The temperature is important with TPU. I like to run TPU at about 205, a build plate temperature between 50 and 60, and the print speed normally I would have set around 50 for like phone covers and that kind of stuff. Just slows the head down so that the gun can kind of glue its way to the seams together. So you kind of have to experiment with different speeds. I've gone for non-brim because it's reasonably thick, and TPU is pretty sticky anyway, and it's not like traveling very high, so you're not going to get any warping. Yeah, TPU doesn't. It's a very flexible material. I've gone for middle slicing tolerance, and pretty much, yeah, everything as standard. So we'll see how that prints out. Don't forget you can preheat here as well. So if you wanted to preheat your build plate or preheat, this is the latest Cura 4.61. I think it's in 4.6 that it starts with a preheat option. You have these 2 buttons here, so you can set your temperature and preheat, which is quite handy. Of course, you can do that with an Octoprint. You can, preheat here as well. Most people preheat the bed first and then preheat the head afterwards. I think we've mentioned that a couple of times. Because it's important for the bed to reach a nice even temperature throughout the bed. Otherwise, you end up with sometimes hot spots and cool spots within the bed. So yeah, cool. So I'm still working on printing out the Grumpy Modeler's Pylon Racer, and I might post some more videos up on that learning exercise. It's not much different to printing out the 3D Lab stuff. He's got some interesting things going on. He's thought this through quite a lot. It's obviously a very chap called Tor. I may have mentioned him up on pretty certain. I think I might have included some information on Grumpy Modeler. So he's a Norwegian. He's an engineer, and he prints out some amazing stuff. He makes some amazing stuff. I check out his website. He's got a website, and he's got the YouTube channel. So go and have a look at Grumpy. That's a great name for it. Grumpy Modeler. There you go, Grumpy Modeler. Yeah, go and have a look at Grumpy Modelers. Actually, no, that's another. That's another. That's not the same. This looks like there's two Grumpy Modelers in that case. Let's look at my history. It's easier if I look at my history. Yeah, okay, there you go. It's this Grumpy Modeler. That's more like it. This looks like a couple of Grumpy Modelers up there. But he has got some really cool stuff that he's doing. And what piqued my interest and my son's interest is this pylon racer he's made, which is free. He does some other ones which you only pay a few bucks for, but he has got a pylon racer up here, and you can download it for free, and it is very, very good. So I do a quick search in there and type pylon in amongst his videos, and you'll find his what they call a 400 pylon racer. There are several flavors of the wing, so you can actually decide on whether you want a small wing, because the pylon racers generally are quite small and fast, as you can see on his sofa. But you can actually do the larger wing and turn it into a glider. So in fact, there's several models in one in this. If you look carefully, you'll see there's different fuselage sections, some with an engine, a Cox B piston engine, obviously one with electric, and then one with a glider nose. So you can actually have a glider with a glider nose. I'm printing out the one with a glider nose, and yeah, all the sections are in here. One has a wing latch, and one has a screwable wing, with a captive nut on the inside. So I've gone for the large wing with a captive nut, and there's also a wing joiner in there as well. So if you don't want to pay for a carbon fibre rod, you can actually print your own wing joiner in some very strong PLA. So have a look at it. But I think what's interesting about his design is that he's thought about things like warping, and providing you've set your experimental slicing tolerance to middle and not exclusive, it will slice these pads as well. And these pads are here, and they adhere to this thin section, because you can see where it's very, very thin here. And this prevents warping of this layer here. Because if you didn't have that, high probability is, unless your bed adhesion is really good, and in some cases, even when it is good, this will warp upwards. These pads prevent that happening. So if you make sure that your adhesion is good and everything's dialed in, then these pads will adhere to the tip and stop that warping. All right, catch you later.